once I have these numbers, I can also introduce a new concept, a new metric, right, which is easy enough to understand. I am going to call it the hardware utilization efficiency. And the idea of hardware utilization efficiency is simply this: if I have a piece of hardware, let us say an adder, and my overall schedule takes t time units or n time units in this case, right, potentially I could have done n additions with that one piece of hardware. Okay. The question I am asking is, how many am I actually doing? Take that ratio, okay, and multiply by 100 in order to convert it into an efficiency percentage. Okay. So in this case, let us look at the multipliers. Potentially, how many multiplications could I have initiated within 5 time units if I have 4 hardware multipliers? 20, right? Each of those multipliers could have initiated, not completed, it will take 2 cycles to complete, but that is okay. But it could have initiated one multiplication operation on every clock cycle. How many are actually executed? 4. I have only 4 multiplications. So the hardware utilization efficiency for the multiplier is equal to 4 by 20 into 100, right, which is basically 20%. So how do you visualize that? Essentially what we are sort of saying over here is, I have a piece of hardware that is capable of doing some computation, right, and I am not using it to its full potential. Only 20% of the time it is actually occupied in doing something useful, right. It could have done much more work, but because of the fact that I do not have enough computations to give it, or rather because I have put in too much hardware, I end up underutilizing the hardware. Okay. The situation for addition is slightly better, simply because I have used only 2 adders, right. So let us do the calculation. The maximum number of possible additions is 2 into 5, so that is 10. The actual number of additions is once again 4. So the hardware utilization efficiency for the addition operations is 4 by 10 into 100, 40%. Slightly better, but still pretty poor. What is the ideal efficiency I would like to see? 100%. Okay. In other words, if I have a piece of hardware, on every clock cycle it should be doing useful work. That is my ideal goal. In some sense, this is a good way of straight away saying, is my architecture optimal or not, right? Because if I find that I have a certain number of computations to perform, I have got some amount of hardware which is doing that computation, right, and I am able to do this calculation and say that my hardware is running at 100% efficiency, every piece of hardware that I have put in there is running at 100% efficiency, I am done. It is essentially what it means is I can't improve upon the architecture. Okay. In this case, obviously I can. Just thinking back about the previous, the actual problem that we used for illustrating folding, right. For the original folding example, what did we have? N was equal to 4, the number of multipliers was equal to 1, and the number of adders was equal to 1. So what was the hardware utilization efficiency of the multiplier? The number of operations was 4 divided by the maximum possible operations with 1 multiplier and 4 time steps was also 4, 100%, and similarly for the adder also. So that kind of architecture is basically our goal, right. Of course, in terms of the overall hardware that I use for my system, when I finally implement this, it turns out I also need some switches, right, some counters which basically go 0, 1, 2, 3, etc., some switches that are basically switching different values, they are basically multiplexers, right, and some registers to hold intermediate values. So it's not very clear how you can define a hardware utilization efficiency for those kind of things. They are of course required, you cannot sort of reduce them in any way. But as far as we are concerned, the assumption we are making for now is the bulk of our cost, whether the cost is in terms of actual rupees that you pay to build the system, or the cost is the area occupied by the hardware, our assumption is that the actual hardware units, the adders, multipliers and so on, are the more expensive ones. So that's why we usually do the efficiency computation on those. Okay. So our original folding example had 100% hardware utilization efficiency for the adder and multiplier. The ASAP schedule that we just saw has 20% for multipliers, 40% for adders.